What is Vantablack? Vantablack was originally designed for use in space travel and optics as an application on sensitive materials to help improve the visibility of distant objects being studied. For example, coating a telescope in Vantablack absorbs glare, making it easier for users to see distant stars and planets. Surrey Nanosystems' first Vantablack process used chemical reactions to grow millions of microscopic filaments of carbon nanotubes, CNTs, to the surface of the object being coated. The CNTs stood on end and were packed tightly against each other. The CNTs absorbed nearly all the light that reached the object, making it appear like a black void. Normal black objects or pigments absorb light. That's why a black car gets hotter on a sunny day than a white car. But they still reflect enough light to be seen. The goal of Vantablack is to absorb as much light as possible, which, when successful, strips the object of visible depth and texture, leaving only a silhouette. Newer versions of Vantablack use different arrangements of the carbon nanotubes, enabling more traditional application techniques to achieve a similar effect. These versions can be sprayed on, using robots, and don't have to be grown in a CVD reactor. That makes Vantablack more versatile and explains how it ended up on the high-tech space equipment. Vantablack is still hard to manufacture, and it's expensive, so it's not available for sale commercially. But Surrey Nanosystems does provide samples to universities, museums, and research institutions to display. And because it requires such a special application, the company has licensed its Vantablack SVS use only to artist Anish Kapoor of Kapoor Studios UK. It's not like just anyone could just call up and acquire a couple gallons of the stuff anyway, but the move ruffled a lot of feathers for going against the spirit of the art community. But other artists have proven you don't need a high-tech lab or a ton of money to get a similar effect on a small scale. Artist Stuart Semple created two matte black acrylic paints, Black 2.0 and Black 3.0, which are pretty darn black. Though they are not the blackest blacks in existence, Semple's site notes that's the trade-off for being affordable, accessible, easy to use, and available online. See Now That's Interesting below for more details. In fall of 2019, engineers at MIT revealed a new, even darker black coating, which is capable of absorbing 99.995% of visible light. MIT's coating is also made of vertically aligned carbon nanotubes, CNTs, and was developed for optical and space science applications. Still, others in the art community and elsewhere are invested in finding the absolute limit of the blackest possible black. So it's possible we may one day be able to capture those remaining hundredths of a percent of visible light. How does Vantablack's absorption rate compare to other dark materials? Vantablack is known for its ability to absorb up to 99.965% of visible light, making it one of the darkest materials. It surpasses traditional black pigments and even some newer materials, but an MIT-developed material has achieved an absorption rate of 99.995%, slightly outperforming Vantablack. What are the potential applications of Vantablack outside of the art world? Beyond artistic use, Vantablack's high light absorption rate has practical applications in space and optical science, such as increasing the sensitivity of telescopes and preventing stray light from interfering with spaceborne instruments.